This is the documentation page of JAX, and in particular, it's the quick start. And, normally, if you wanted to learn a library, the quick start is the place to start. However, in this video, I'm going to take a slight detour by trying to see if Claude Code can teach it to me instead. The thinking here is that by offering something interactive where I can ask Claude a question, it can then generate me code, and then I can immediately play with the code, I might have a more engaging learning experience. I don't know what's going to happen though. I'm going to be recording this live. The only editing that I will do is I will cut out all the bits where I'm waiting for the LLM, but it also means that you get a fair representation of what it is like when a senior data person like myself uses a tool like this to learn something new. So let's get started. I have a file called learnjax.py, and I'm gonna tell Marimo to start it in sandbox mode and with a watch flag. That watch flag is important. That's the thing that's gonna make sure that when Claude makes an edit, the browser just does a live update and I don't have to restart everything. Now, if you're doing this yourself, I do recommend splitting the window of sorts where you might have a browser on one side and a terminal on another. That'll totally give you the best experience. It's just that this is YouTube, some people watch on mobile, so for screen real estate purposes, I'm not gonna do that. But if you're doing this for realsies, of course, split the window. It's just so much better. And there we go. I can confirm that the page loaded, so that's good. Next up, I'm going to start Claude, but one thing that's good to point out is that I did do my homework, so I prepared a claude.md file. There's going to be a link in the show notes. This file has all sorts of good suggestions for Claude to understand Marimo a bit better, so that's something I do recommend configuring before doing the exercise. But having said that, I can now start Claude. And as a place to start, I figured I would immediately want it to just implement something in JAX. Usually if I have a tangible example in front of me, then it's easier to pick apart the stuff that I don't understand. So I think it would be fun to just say, implement a linear regression using JAX in the learn-jax.py file. Yep. Keep it minimal. Show and point out some features that make JAX unique and a joy to work with. We'll see about the joy part, but if it's able to show me some things that are at least a little bit specific and unlike other libraries, that will be nice. And I should write that down. In particular, point out what makes JAX different. Keep it minimal though. MVP is the name of the game. I'm writing this explicitly because Claude does have a tendency to do 10 cells in one go when only 2 cells would suffice. And let's run this in plan mode actually, just to play it on the safe side, because I don't feel like going through lots of code. I just want to have a simple example, and I do want to confirm that the plan includes only that. Okay, so it's made a plan. It's got a couple of features like the gradient function, the JIT function, and the VMAP function. Those all feel good to showcase. And although I think 8 cells is a bit on the long side, it does feel like all of these cells have something specific that they're doing. And yeah, this will be like a fun example to go through, I think. So yes, auto accept all the changes, and then I'm going to go back into the browser. And because I turned on the watch flag, I should see this notebook update whenever Claude makes an actual change. And boom, some code got added. It needs to install a couple of packages now, which, okay, sure, go ahead. After installing, I can see that it wants to show me some markdown cells, which is a nice touch. So what makes JAX special? Gradient, JIT, VMAP. It needs to have an extra new line there to actually turn that into a proper list. Minor detail, but fair enough. Gradient, JIT, VMAP, and functional programming. So grad is probably some sort of gradient computation thing. JIT stands for just-in-time compilation, I think. And VMAP, if I had to guess, yeah, vectorized mapping. Let's have a look. So in this cell, we are generating random data, I think. And, oh, it's only doing a one-dimensional linear regression. That is a bit of a bummer, but I can ask it to update that in a moment, I think. It's just got 100 samples with a bias term and a weight term. Okay, fair enough. Then it is going to do the JAX difference. Okay, so we have parameters. It can do unpacking and then do the matrix multiplication that you would normally expect from a linear regression. That unpacking is interesting though. Oh, we've not defined, oh, and that's because the parameters aren't defined yet. Okay, fine. So parameters haven't been defined yet, but this is a function that can accept parameters. Predictions come out, and similarly, I also have a mean squared error loss. Again, parameters go in, now also a label goes in. Inside of that, we use the predict function. We calculate the mean of the squared error. This all reads as if it's NumPy, so that's also good. Then now we get to the magic of gradients. And that is also kind of a cool trick, I think. So then the idea is you have your mean squared error loss function, you wrap that with this gradient, and then you've got your gradient function out like so. And you don't want to do that with a decorator, you want to do that with a proper function, because that way you have the actual loss function and its gradient. Okay, and that's, I think, a nice notation, actually. So that's a cool thing of JAX. Then apparently what you can do is you can take a function called train step that accepts params. It accepts a learning rate, does all the loss stuff, and you can JIT compile this whole thing, apparently. And it's going to compile the Python code to XLA, which I believe is a linear algebra library. I'll double check that in a bit. But yeah, I've got a train step function that's going to get compiled, and we're updating these parameters in place. We've got some sliders down below here for epochs and learning rate, as well as a training loop. And this is where I think it gets interesting. So the parameters that I mentioned before, that's a tuple. That's what params is. Then we're able to run a single training step that gives us new parameters that can go in there again. And then we have some losses that we append. Okay, and we've got some sliders now. So I think if I hide some code down below over here as well. Yeah, there's a training chart. Let's maybe zoom out. And I can specify the number of epochs. I can maybe move that up a bit. We can see that at some point, all of this stuff converges. Nice Altair chart with a logarithmic Y scale. And if I change the learning rate, maybe set that a lot higher, then we can see the convergence happens a lot quicker. If I set the learning rate a lot lower, the convergence happens a lot slower. Okay, fair enough. We have a somewhat functional linear regression. I do want to maybe change a few things about it. We can see that there's a good fit as well. Okay, that's all fine, well and good. But the main thing in terms of learning goes, like, if I were just to have a look at this and get an impression of what makes JAX unique, is you can pass in tuples. You can unpack that, which is what's happening inside of this loss function over here, right? So we've got a predict function over here that accepts parameters. Those are unpacked, and then JAX just kind of knows how to deal with it. So that's, interesting. But I do want to understand the moving parts. So I have a gradient function, and that's good. But when I do the JIT compilation here, does it also compile everything inside? Because I kind of wonder now if this mean squared error loss function, if that's now also compiled as a side effect of doing this. So that's a question I've got. Let me just copy that and then go back to Claude. This one step, and I can just paste that whole thing in, I think. Does the JIT here also compile MSE loss and loss gradient? And it says yes. Okay, so that is actually a neat trick. I'm assuming it's not hallucinating at this point, but the fact that you only got to add this JIT there once, that is definitely kind of nice. And let me just go back to the train loop one more time. Right, okay, so this all looks well and good, but I think I've not really seen it do the vmap function, which it did mention on top. And I think that's also because this initial W over here is only a single variable. So I'm going to go back. I would like to see vmap being used. Can we change the example such that we have multiple columns going into the regression? Also use a larger data set so we can see the effect of vmap. I wanted to generate extra rows as well. I don't think I got to go do plan mode now. This feels good. So it's going to update the entire notebook now. And if this was a kind of a real life scenario, this would be an excellent point in time to maybe also explore the docs, right? But I'm recording, so I'm just going to stick to this. But I do think being able to just generate examples on the fly, that feels super nice, actually. And I'm actually pretty impressed with Claude as well, because JAX is one of these libraries where it's well documented, but it's not that popular. So the fact that I was able to generate all of this just like that is definitely kind of cool. I would have expected that for PyTorch. I wasn't sure if I could expect that from JAX, to be honest. Now that I'm looking at this, by the way, I'm just going to ask it to also remove all the markdown, use a few comments instead. That's mainly because I don't have a lot of screen real estate right now, and I don't want to do a lot of scrolling, but that's a bit of a detail. Okay, and I can see it already made a few changes. I now have a slider to define the number of samples and the number of features, so that's definitely nice. I can also see the data that we're simulating now actually uses that, so that I would argue is also nice. The rest of the code looks the same. Let me check if it's... Okay, it is done. So making that change didn't make the predict or loss functions any different. It's still unpacking, and that's probably because it's all matrix multiplication anyway. So that was the same. Again, we use the gradient. Again, we do the JIT compile thing. There's a few extra steps when it comes to training because we have an extra batch size slider now. And apparently that's because the train loop is now also different. We're going to shuffle X and Y, and then we're going to go through all sorts of different batches. And we're going to do a train step for every single batch. And only when we've gone through all the batches, that's when we've done an epoch. Then we've got our final parameters and such. And okay, let's, again, just kind of hide this. Maybe change the learning rate to be a lot quicker. Yeah, again, this is linear regression. It's a convex function, so it shouldn't have any problem with this. And if we set the batch size to be smaller, there's not really a big difference. If we set it higher, oh, interesting. It tends to perform better with smaller batch sizes. Oh, and that actually makes a lot of sense too, because it's a bit of a math argument, but a linear regression is a convex function, which means that as long as you're stepping in the right direction, you will eventually just always get there. And that means if you're able to make more steps, then you're going to get there quicker. So setting a very small batch size means that in the end, you are going to make lots of small steps, and setting it higher means less steps. So that's the phenomenon that we see here. Okay, so that's kind of cool, but now we get to the fun bit below where there's now also a VMAP comparison for performance. So we've got a predict loop, and it's going to do a batch predict VMAP JIT. And how do we get there? Batch predict VMAP. We already had a prediction that was vectorized before, but now we also have okay, we got to zoom in on this one. So before we had a function that was just vectorized, and now we have a function that is not just vectorized, but it's also been compiled. And that means that we can do a little benchmark. We can loop, and we can just time ourselves as we are looping. And then we get a nice little chart at the bottom here. The normal Python loop, the vectorized, and VMAP JIT. VMAP JIT is actually a little bit slower in this case. That might be, I wonder, because it has to do a warm-up maybe? Oh no, it's doing the warm-up right here. Oh, that's interesting. Okay, so that's pretty cool. I think I get a bunch of things now, but what I would like to do next is the fact that everything is convex is cool and it's a linear regression and it's fine. But the next example, I think I want to do classification and maybe do like a proper neural network instead. And I'm going to go back and I'm going to ask it to remove all the markdown, use a few comments instead. Let's also drop the linear regression and move to classification. Feel free to throw away the old cells and pick a standard sklearn model, or dataset, I should say, not model, scikit-learn dataset for the data. If I remember correctly, and this is because I did use JAX like a few years ago, we had VMAP, but we also had PMAP. The idea there is that you're also able to not just vectorize and maybe JIT compile your functions, you're also able to maybe run them in parallel. So I'm going to say PMAP is also a feature that I would like to see. And let's also hit plan mode now. But already this is pretty useful. I can definitely see the moving parts. I like the fact that you can just use functions. So okay, this is definitely an interesting library. Being able to play around with it definitely helps. And again, normally as you're waiting, you would check the documentation, partially because that way you can also learn about some other features you would like to throw in the mix. But let's look at the plan, remove all markdown cells, switch to classification, logistic regression. Actually, I don't want it to do logistic regression. Instead of logistic regression, let's do feed forward with a few hidden layers. Also with an activation function in there. Partially, that's because logistic regression, again, converges on a single optimum by just taking steps. That's an easy solution. If you have multiple layers, it becomes non-convex, so that makes it more interesting. And the scikit-learn dataset, it wants to take the iris dataset and the digits one. The digits one is MNIST, I think. Digits dataset is MNIST, right? The rest does look good, so let's just add that in. I'm always happy if I do this in plan mode. It's a thing with Claude. You do have to run the plan mode thing because otherwise it'll just yeet off in a direction you're not interested in. I would not have liked to see this whole example with just logistic regression on the iris dataset. That would have been too simple. The rest looks pretty good though. Okay, and it's saying that the digits dataset in scikit-learn is smaller and it's an 8x8 digits instead of a 28x28 one. So it's like MNIST, but it's also gotten way less samples, but I think it's fine. Yeah, so the 8x8 digit one, that's quick to train, that seems fine. Scikit-learn, Altair, JAX, that feels fine. Initialize weights, forward pass, gradients, JIT, VMAP, PMAP. Great. So let's see what comes out of this, but part of me is thinking that it might be fun to also try out a couple of different stochastic gradient descent variations, right? Like we can ask it to maybe generate, or there's probably in a library, like you've got Atom, you've got all these other optimizers. But given that you've got gradients, right, you might also be able to do a fun little math trick where you take the gradient twice, and that way you might be able to not just know the direction that you have to move into, but you might also be able to use Newton's method to figure out how big the step size should approximately be. It's a total brain fart and a bit hand-wavy math-wise, but it sounds like a fun thing to try after this, actually. And I'm mentioning this because building your own optimizers in Keras, that was always like a huge pain, but it feels pretty easy to do here. Okay, so I'm back in the notebook and it's generated a whole bunch for me and I'm eager to have a look, but what I did first was just, scroll through and glance if it was able to do what I wanted it to, and it made an error. Apparently there's this one function, and this function is defined in the notebook, and it is using an old API. And I'm actually kind of happy that this happened because it allows me to show off this one trick you can actually do with Claude and Marimo notebooks. So there is an error, run uvrun learn-jax.py for me. Because Marimo notebooks are Python files under the hood, you can just UV run them, which means that if Claude runs it, it is able to see the same traceback and error message. So hopefully that is also enough for Claude to fix it. And if you were doing, say, a data analysis, then you probably want to fix it by hand, by the way, but because this is a library that I'm not that familiar with, this is actually a really pragmatic way to go. And there you go, there's an error. You can hit Ctrl-R to also inspect the error in full, or there we go. It's found the same error as I did, so that's good. And you can also see that it's using not tree_map anymore, it's doing tree.map. So that's also good. It's going to run the file one more time to confirm that there are no further errors. And it seems to get a bunch of output, so I'm pretty sure it all works. And there's even a message. So cool, we can now inspect the notebook. Keep in mind, you can always UV run the same notebook, and it's a really nice way to do debugging. But anyway, we now have a few functions that are different. There is now a forward function that implements the forward pass. It takes all the parameters except the last one. Okay, so this is the forward pass, but it's not doing any activation. That's happening in the loss function. I wonder why? I mean, it does give you flexibility, which is kind of nice, because you can change the loss function this way, independently of how the prediction is made. So that's actually kind of fair. We're also calculating the accuracy here. And also for the predictions, you can just take the argmax. You don't necessarily have to care about the probability value. Okay, fair enough. So that all looks fine. Pretty interesting to see all these functions, mainly because I'm used to PyTorch, where everything's just more like an object. But I guess you're also implementing the same thing inside the methods. So it's not that different, actually. Then we get to the train loop. It is doing a random shuffle every time there's a new epoch. Then it's going through all these different batches. It's going to do some training. We're going to log the losses, and then we've got our training loss. Okay, so let's just hide a few elements of that code. Let's zoom out just a smidge. And yeah, the loss keeps on going down, but the accuracy is like pretty much the same. Let's set the learning rates to be super duper low, and let's set the batch size to be like super big. Yeah, we see the same story in terms of convergence. It's also not the hardest data set, actually, so it's not that surprising, but okay. That all still works. Now in this final cell over here, I can see that it is using the parallel map to do a parallel prediction. And then if I scroll down, it tells me a time amount. And if I scroll down, it does the same thing, but then with the VMAP and the compute and the just-in-time compilation. And yeah, the parallel thing definitely is quicker. So, okay. That means that I now understand all the different building blocks. Okay, so I fast forwarded in time a bit because as a final step, I figured it might be fun to see if I can get Claude to implement that custom optimizer that I was mentioning. I think I got it to work. It's just that it did take a lot of back and forth. A lot of, oh, it doesn't work. A lot of, oh, you forgot to maybe add a JIT here. Can it be faster? A lot of that. And in the end, I have a notebook with a benchmark. When I scroll all the way at the bottom, I can see that my method sits between atom and normal stochastic gradient descent, so I was pretty happy with that. And I even got Claude not just to show me the epochs, I can also compare based off of wall time, so to say. So here I can see that atom does take a little bit longer than maybe my thing, but atom is still quicker to converge. And, being able to quickly whip out a notebook that does this is pretty darn cool. But it also serves as a lesson because if you are keen to maybe use a tool like Claude to learn a tool like JAX, it is great that Claude is able to run this as a Python file because it helps it to debug. It is also great that the notebook can give you charts that help you understand what's going on. But there does come a time when the learning doesn't come easy and when you are going to have to do proper effort. Because in this particular case, I have a implementation. I just don't know if it's correct yet. All these charts do definitely help though. And what I do like to think is that after you've done the syntax, it can be good to maybe take a step back and see if you can get Claude to build something that's a little bit more comprehensive and end-to-end. And then from here, you do have code that works, which means that now is the time to actually poke at it. If I take this quasi-Newton thing that it implemented just as an example, then I can see that it calculated a gradient here, but it's calculating 2 more gradients here, and why might that be? And if I wanted to double check, that also means I maybe have to grab a piece of paper and a pen to, do the math. That is definitely still learning, but it is a different phase of learning, I would say. Doing the syntax stuff with Claude, that is easy. That is something that Claude can just regurgitate from the docs, so to say. But getting proficient at it, Claude can still definitely help you, but there are also these moments when it really helps if you're able to challenge yourself. The easy bit is going to be for it to generate the hello world. The harder bit is to see if you can generate more complex work and to see if you can understand all the parts that are being generated in between. And typically that means that you're going to review harder and harder to understand code. Learning a new big tool like JAX is kind of like learning to play StarCraft. It's really easy to get started, but even if you have a tool like Claude, mastery can still take a while. And just good to keep in the back of your mind as you explore harder and harder things to do with a library that you're trying to learn. But yeah, having said that, I do think Claude Code for learning and using Marimo as a view definitely works. Try it out if you haven't already.